So this video is about converting standard notation and scientific notation, numbers between standard notation and scientific notation. So here we have a number in standard notation, the number 29,000. So we're going to write 29,000 in scientific notation. Scientific notation is when you write a number as a number between 1 and 10 times a power of 10. So the way we do that is, this has a decimal at the back there. You're going to move this decimal until you have a number with a value between 1 and 10. So I'm going to move this once, twice, 3 times, 4 times. So if you move it to that spot, you have the number 2.9. Now obviously 2.9 is not equal to 29,000, so we want to have the same value of 29,000 but written in scientific notation. So we always multiply that then by a power of 10. So 10 raised to some power. We need to put an exponent here. And the exponent is always going to be equal to the number of times we had to move the decimal. So we can say we moved 1, 2, 3, 4 times. So this would be 2.9 times 10 to the 4th. So 2.9 times 10 to the 4th, 10 to the 4th is 10,000. So 2.9 times 10,000 is 29,000. So these two numbers have the same value. One is written in standard notation and the other is written in scientific notation. Again, scientific notation is the product, or when you multiply, the product of a number between 1 and 10 and a power of 10, 10 to the 4th power. So let's do another example. That was a large number, right? 29,000 is a large number, a number with a large value. Let's look at a number that has a small value, right? We can see here 0.000091. So let's change this very small number into a number written in scientific notation. So the process is very similar. We're going to move this decimal until we have a value between 1 and 10. So if I move it once, twice, 3 times, 4 times, 5 times, I have the number 9.1. But we want to make sure it has the same value, so we're going to multiply it by a power of 10. And the exponent is going to be 1, 2, 3, 4, 5. Now, 10 to the 5 is 100,000, and clearly this number is not 9.1 times 100,000. So when we have very small numbers, instead of having 10 to the 5th, we're going to use a negative exponent. Remember, negative exponent means repeated division, so it's like divide by 10, divide by 10. So if we divided by 10 5 times, we would get a very small value. So 9.1 times 10 to the negative 5th is equal to this number. So key things to remember when you're going from standard to scientific notation. You want to make sure that the first number is between 1 and 10, a value between 1 and 10, and then you're multiplying it by a power of 10, and this exponent will always be the number of times you had to move the decimal. So here 4 times, here 5 times, and then if this was a number of large value, 29,000, this will be a positive exponent, and if you had a number with a very small value, you'll have a negative exponent. So really key to make sure you understand when to use positive and negative exponents on your scientific notation. So that was converting from standard form to scientific notation. So let's show the other way. So now let's go from scientific notation back to standard notation. So here I have a number in scientific notation. We can see a number between 1 and 10 times a power of 10. So we're going to change this into standard notation. So just take that first number that's between 1 and 10 and write it down separately. And then just move this decimal, just reverse of what we did before, move it 5 times. Now I want to move it in a direction that will make this a large number. We know it's a large number because of this positive exponent. Remember, this positive exponent tells us a very large number. It's this 10 to the 5th is like times 100,000. So this has a very large value. So we'll move the decimal, if I move it this way, 1, 2, 3, 4, 5 times, and I'd fill those with zeros. Now I have the number, let's rewrite it. 158,000 or 158,000. We can see we created a number with a very large value, and if we look back here, positive exponent, we know we should have created a number with a very large value. So we know we did it right if we created that large value. So here, let's do one more example. This time, notice we have a negative exponent, and that negative exponent tells me that this should have a very small value. I'll scoot that over a little bit. Oh, there's a little glare there. Let me see if I can not have that glare show up. There we go. So now I'll do the same thing. I'll write this number, oh, sorry, I'm going to move this again. I'm looking at the glare there, I don't like that. So I have 1.2 and I'm going to move it 5 times, but I want to make sure I'm creating a value that is very small. So I'm going to move it 5 times this direction. 1, 2, 3, 4, 5 times. And again, I'll fill these with zeros. So that's going to be 0.000012 or 12 millionths. That's very, very small. And that number is in standard notation. So we can see negative exponent there. Negative exponent meaning very small value. We can see we had a small value when we moved the decimal 1, 2, 3, 4, 5 times. And then that previous example, if we look back at that, it was 10 to the 5th power. And we had moved the decimal 5 times, but we moved it in a direction to create a large value. So that is converting from standard notation to scientific notation, and then back the other way from scientific notation to standard notation.